Okay, as you might expect, we're going to start by looking at what we're being asked for and what we're being given. In this case, what we're being asked for is going to be something about the energy of the system, of our lattice energy. And what we're really looking for then is, in this case, actually the lowest lattice energy. And that's important, right? We got to remember that we're looking for the lowest lattice energy. And what we're being given is some sort of information about what lattices we need to consider. And when we think about lattice energy, the thing here to realize is that we're thinking about electrostatic potential energy. And we have an equation for handling electrostatic potential energy. We know that the energy of the electrostatics is going to be somehow associated with the charge on one species, the charge on another species, and then the distance between those two species, R12. When we're thinking in terms of our ionic compounds, what we really want to think about then is something about a cation and then also an anion and how they interact with each other. And so in this case, one of these charges is the cation, the other charge is the anion, and then we just have to think about the separation between those two species. So R12 is going to be the distance between these two species. And if we want the lowest lattice energy, what we need to do is we need to minimize the numerator and we need to maximize the denominator. So we want this to be small, which means that we want small charges. We want this to be large, which means that we need large atoms. We can see that up top, when we're talking about charges, is going to be the charge multiplied by each other, and so that's going to make the charges actually a little bit more important. And so what I would do is I would immediately start by asking which one of these has the smallest charges. Alright, so let's just work down our list. We know that calcium is a 2 plus charge. We know that sulfur is a 2 minus charge. We know that sodium is a 1 plus charge. We know that NaCl is a 1 plus or a 1 minus charge. We know that magnesium is a 2 plus and that sulfur is a 2 minus. Aluminum, if you look at the periodic table, you can convince yourself that's going to be a 3 plus and that nitrogen should be a 3 minus. And then if you look where rubidium is and where bromine is, rubidium is going to be a 1 plus, bromide is going to be a 1 minus. And so immediately what we can do is we can cross off anything that has, we only want to consider those species that have the smallest charges, right? We know that it's going to be the small charges that give rise to the correct answer, or the lowest lattice energy. So let's get rid of A, let's get rid of C, and let's get rid of D. And now all we have to do is we need to consider what the right answer is between B and E, and our remaining consideration is to look for large atoms. And so all we really need to do here is decide between sodium chloride and rubidium bromide which one has larger atoms. And hopefully you can tell that here we have larger atoms. In fact, the largest atoms given on this list. And so that agrees with this idea that we need large atoms, and that ends up being our correct answer. Alright, our next question is not necessarily about lattice energy, but it is in turn a question that tries to address how we know what is ionic and what isn't ionic. And so here, really what we're being asked for is to identify something that's not ionic. This is the same question really as trying to decide what is ionic. And so we can go down the table or our list of choices, which are our givens, and decide which one of these is ionic and which one's not. So there's a couple different ways to come at this question, but when we think about what makes an ionic compound, we know that an ionic compound is something that has a metal plus a nonmetal. This together is an ionic compound. And so, for a problem like this, I would just go down and eliminate anything that's immediately clearly an ionic compound. Sodium is a metal, chlorine is a nonmetal, so that's an ionic compound, which means it's not the right answer. Barium is a metal, chloride is a nonmetal, cesium is a metal, fluorine is a metal, sulfur is a nonmetal, and so is fluorine, so that looks like it could be the right answer. And then for E, calcium is certainly a metal, bromine is a nonmetal. And so in this case, what's left is the sulfur fluoride. They're both nonmetals, and so this ends up being a a covalent compound. Or let's call it actually a covalent molecule. And since that's a covalent molecule, and the rest are ionic compounds, because they have the metal and the nonmetal, then they're the wrong answers. And we're left with D as the correct answer.